Okay, so last weekend I had to buy a new computer, and with that came lots of challenges. So hopefully this video will go okay. It's my first one on the new computer. I don't know why there are these green blocks. I wish I could figure that out, but anyway, we'll just live with it for this video. So in 3.1, we're going to be talking about quadratic functions. So, we're going to be talking about quadratic functions, and that has to do, or examples of when you would use a quadratic function has to do with projectiles. So, a ball goes up, the ball comes down, and it makes this kind of parabolic shape. And that's what we're going to be talking about in this section. But we use quadratic functions in other areas like business and health, medical things and stuff. So anything that's parabolic, though. But I wanted to talk just a little bit about projectiles because they're based on gravity. You shoot something up into the air, a rocket or a ball, and it's going to come back down because of gravity. Okay, quadratic functions can be written in the form f of x equals ax squared plus bx plus c. Now, they don't really give this form a name. I would call it the general form, but all quadratic functions can be written in that form, where a does not equal 0, because if a were 0, then you'd have a linear function. Okay, so we describe this in different ways. So let's say we have a parabola, and we know that this can happen. Let's try to do like a basic parabola here. Trying to draw it nice. And we know because of transformations, we can shift that parabola around. A quadratic function is one of our common functions. This point right down here, where you see it's changing from decreasing and then it's changing to increasing, or you could have like another parabola that goes this way, where it's changing from increasing and then it's changing to decreasing. That point, though, is called the vertex, okay? So that is the vertex. It's either a maximum or a minimum, but I guess you could say it's a relative, like in this case, it's a relative relative min. And here you could say it's a relative max. But we're going to talk about that more in a minute. But it's the vertex. It's where it's changing either from decreasing to increasing if it's a right side up parabola, or increasing to decreasing if it's an upside down parabola. Now, there's a line that goes through the vertex, a vertical line, and that's called the axis of symmetry. Okay, so the axis of symmetry is where you could fold your paper on that axis, and the parabola is symmetric about the axis of symmetry. So parabola, that's the shape that we get when we graph a quadratic function. Parabola is symmetric about the axis of symmetry. Okay. When we had the common function, before transformations, it was symmetric about the y-axis. But now, see, we can move our parabola around, and that's going to change the axis of symmetry. Okay, but this is a vertical line. So x equals, and then whatever equals. Okay, these points we talked about here are maximum and minimum points. That vertex is going to be either a maximum or a minimum point. Okay, and we'll talk more about that as we do more examples. And that's all for this one.